Now let's focus on calculating nonce. For our difficulty level, we have 3 this time. So 3 is the difficulty level, and we have to define the setting at the top of our file. So here we'll write const, then we'll write mining difficulty. We'll set this to 3. Now that we've written that, let's go down below. We included here using hash this FMG, but we don't need this, so we'll delete it. Let's go down below further, and we had add transaction. And below this add transaction, let's add on a new method. And to the right, we have our pool right here. Later on in our lecture, we'll sync what's in our pool, so the transactions that are stored in the pool need to first be copied, and that's the method we're going to create from now. We'll type func, then BC blockchain. This will be followed by copy transaction pool. What's inside transactions right now is copied, and brought over is the method we want to write from now. So next will be transactions, and inside this we'll say make and then create an empty slice for transaction. Then for, and we won't use an index for this. We'll write T, then range BC transaction pool. We'll run this using a loop, and we have the transactions that we defined above. For this we'll append, then write transactions. And within this we'll store new transactions, followed by T sender blockchain address and T recipient blockchain address, and also include T value. We included these 3 data fields. So we've created a new transaction and included transactions. So we've simply just copied it. Next, we'll return transactions, and we have the transaction that we copied, and we're returning the slice of the pointer that we copied. Now on to our next step. We have our nonce, previous hash, and transaction. We'll refer to these 3 to write a method to compute the difficulty level. First, we'll write func BC blockchain, then valid proof. Then we'll pass in nonce. At first, this value will be 0, but this value will increase as we calculate. Nonce is an int, previous hash will be 32 byte, then transactions, and we'll pass in the slice with the pointer for the transaction struct. This is all followed by difficulty, which will be 3 at this time. Then, in order to see if the first 3 values are zeros, we'll return with bool. So now, how will we do this? First, we'll define 0 as strings. Then we'll use repeat 0, difficulty, since we want 3 zeros. So 0, 0, 0. Then we'll write guess block, and for now, simply write block. Our timestamp will be 0, followed by nonce, previous hash, and transactions. Right now, our program is telling us we have errors, and that's because I didn't specify the fields. The order of the fields don't match. So let me return to our block, and right now the leading field here isn't timestamp. We'll bring timestamp to the very top, and our order will be timestamp, nonce, previous hash, and transactions. We'll return to our code that we were working on, and we don't see any more errors. When you are going to specify the order, then you have to follow the order that's used in your fields. Your option is to reorder your fields or include, for example, 0 for timestamp. How you handle the error is totally up to you. Now you want to compute the nonce by using guess block. So we'll write guess hash str. Then we'll write fmt s printf, and then write %x, then guess block hash. We'll return as a string. Next we'll return guess hash str. We're looking at the leading 3 values, so we'll write out the 3 leading values and determine if those values are all zeros. We'll return it as a bool. We want to determine if the 3 leading values are zeros, and with this we've created a method that will do exactly just that. The nonce value will change, for example, to 0, 1, 2, 3, and keep on increasing until we have our nonce. So now we want to figure out our final nonce value. The cycling through of solutions to guess the nonce is referred to as proof of work. We'll write func BC blockchain and proof of work. This is our method name, and we want to return nonce, so we'll write int. And now to how to approach this. First, we'll write transactions, and if you recall, we previously created copy transaction pool. We'll take the contents of our transaction pool and then write previous hash. Then we'll refer to the hash in our BC last block. For example, let's say we have 2 blocks right now. We're referring to the hash from this block right now. This is our hash, and we also just passed in our transactions. What's left is our challenge, and now we want to refer to our nonce. First, nonce is, let's say, 0. Next, we'll write for BC valid proof, and we're passing in nonce, previous hash, transactions, then mining difficulty. If this 0 that we inserted in nonce is acceptable with our valid proof, then we want to figure out the nonce. If we entered 0 and it isn't correct, then this will become false. We want to run the code until we get the correct nonce, so we'll do this with a for loop. If we don't compute the correct nonce, then we'll take nonce and add 1. We'll add 1 and come back to this line. If we input 1 and the code returns false, then we go through another cycle. We'll continue this for loop until our statement is true. Once this becomes true, we can break from our for loop. This means that at this point, our hash contains zeros for our 3 leading values. Once we exit this loop, we return nonce. Once we've gotten this far, we want to use this method, so we'll scroll down to the bottom and refer to our main function. We'll create a line before our create block with our 5 and include nonce blockchain, then proof of work. We'll compute our nonce here and insert that value in our line below. We'll copy this again and go down below. We'll repeat the same process. We'll compute nonce here, and in our next line below, we have 2, which is a random number, but we'll replace that with nonce. Let's run our code with this, and let's focus on our nonce results. First, we have nonce as 0. This is our initial setting, so nonce is 0. For the second chain, we have nonce as 9200. For our third nonce, we have 814. We're able to confirm here that nonce is being computed. If you do find this to be difficult to follow, then let's refer to our valid proof method that we just created. We can include fmt print ln and include guess hash str. We'll print this and run our code. And when we do, we see a list of hashes, but if you go to the very bottom, we see our hash with 3 leading zeros. This is our last hash, and with this hash here, we'll return true. Now I'm going to erase this for now, and we've completed our proof of work method. Now let's move on to our next lecture.